We now turn our attention to making measurements about matter. So chemists measure the properties of matter using a variety of devices or measuring tools, many of which are similar to those used in everyday life. So we use rulers to measure length, mass balances to measure mass, and so forth and so on. So, like I said, rulers are used to measure length, balances are used to measure mass. Wow, I actually almost said that verbatim. And then graduated cylinders or pipettes are used to measure volume. So now, while we won't while you won't have a chemistry lab experience this quarter, so that will come when you take general chemistry. If you're interested in getting a head start and looking at some of the common pieces of glassware and apparatus used in the chemistry lab, here is a good video that you may want to watch. But this video is optional, but if you have the time, you can check it out. So measurements made using these devices are expressed as quantities. A quantity is an amount of something and consists of a number and a unit. And so this quantity, the number part of it, is meaningless without a unit. So you always want to include units. So in order to receive full credit, you must report both a number and a unit. So the number tells us how many or how much, and the unit tells us what the scale of measurement is. So for example, when the distance is reported as 5.4 kilometers, we know that the quantity has been expressed in units of kilometers and that the number of kilometers is 5.4. So like if you use Google Maps or something like that, so maybe in kilometers or miles, so both the unit and the number is important. And then we have two different systems of measurement, or we have two common systems of measurement. So the first is the English system of units, which includes units like the inch, the foot, the pound, the quart, and the gallon. And so ironically, this is the most commonly used system of measurement in the United States. So most other countries have moved away from these units or this system of measurement. But one major disadvantage of this system of measurement is that these units are not systematically related to each other. So there's no systematic relationship between the units, and so it's not an easy conversion like in the other system of measurement we will talk about, which is called the metric system. So the metric system includes the gram, the meter, and the liter as base units, and a systematic relationship allows it to, or makes it possible or easier to convert from one unit to another. So simply by moving the decimal place. So there's a systematic relationship between the units in the metric system. In the metric system, there's one base unit for each type of measurement, and we use prefixes to indicate fractional or multiples of the fractional parts or multiples of the base unit. So, and then these are the symbols for the base unit, and then we have symbols for the symbols for the prefix, so like kilos, so K, and we combine that with the base unit to give us kilometer or kilometer. So you need to learn these base units. So learn base units, and then also you'll learn the symbols of the prefixes. So these are the more common ones and the ones I expect you to know. And it may be good to also know micro and nano. So kilo, hecto, deca, base, deci, centi, milli, the symbol for micro, and the symbol for nano. So those are the ones that I want you to know. And so then if it's micrometer, so micrometer, then we would write it as that. So the prefix and the symbol of the base. And so there's a systematic relationship, and so I'm going to show you an easy way to convert between the common units in the metric system. So this is called the magic ruler. So this allows us to determine the direction we need to move our decimal place. So to get from one to the other is the same as moving the decimal place that many times. And so let's say we started here and wanted to go here. So we move it 1, 2 times to the right. So it tells us how many times to move the decimal place and in which direction. So whenever you get your quiz exam, just write this out: kilo, hecto, deca, base, deci, centi, milli. Kilo, hecto, deca, base, deci, centi, milli. So just keep saying that to yourself. And then the base unit, so the gram, the meter, the liter. So that would be here. But you could remember, King Henry died by drinking chocolate milk. So that's a mnemonic that you can use to help you to remember this. So King Henry died by drinking chocolate milk. Kilo, hecto, deca, base, deci, centi, milli. There are other ones. So kings have diamonds, but diamonds cost money. Or you could come up with your own. But that's my favorite one. King Henry died by drinking chocolate milk. So move the decimal place in the same direction and the same amount of times that you move along the magic ruler. So, for example, let's say we wanted to convert between or 0.5 millimeters, so we'd be here, and go to centimeters. So we want to move 1 time to the left. So we have to move our decimal place 1 time to the left. So this would be equivalent to 0.0500 cm. So that's all we do. Move the decimal place the same number of times and in the same direction. So kilo, hecto, deca, base, deci, centi, milli. King Henry died by drinking chocolate milk. Then let's say we wanted to go from 50 km to 50 meters, which is the base unit. So we move 1, 2, 3, 1, 2, 3. So where's the decimal place? So it's here. So I move it 1, 2, 3. So that should be equal to 50,000 meters. Okay, you make the following conversions. So 85 centimeters to millimeters, and then 98 centigrams to decigrams. So pause the video, work through it, come back. Okay, so 85 centimeters, we're here. I want to go to milli, so 1 time to the right. So 850 millimeters. 98 centigrams to decigrams. So we move it to 1 time to the left. So 9.8 decigrams. King Henry died by drinking chocolate milk. And then we have what is called the International System of Units. So this was a measurement system agreed upon by scientists since 1960. So we call these SI units, or which is short for the International System of Units. And this is essentially a modernized version of the metric system. And within the metric system, we have 7 SI base units. So interestingly, the SI base unit is the kilogram, not the gram. So kilogram, length, meter, time, the second, temperature, Kelvin, amount of substance, the mole, electric current, ampere, and luminous intensity, candela. So those are the 7 SI base units. And so in the first part of our chemistry journey, these are the ones that you will most frequently encounter. So a little bit about each of these. So measurements. So mass is a measure of the amount of what contained in the sample. What did we say? So the amount of matter contained in an object. And the SI base unit is the kilogram that we just discussed. But in chemistry, the smaller gram is often more convenient and is more commonly used. So usually we use in our mass balance, we would have it set to units of grams. But we could set it to kilograms, or we could just convert between the two because we have conversion factors, which we will talk about in a later lecture. So converting between units, so this is a conversion factor, so 1 kilogram is equal to 1,000 grams, but for now you know that based on the magic ruler. So King Henry died by drinking chocolate milk, so 1 kilogram is equal to 1,000 grams. Then temperature is a measure of the hotness or coldness of an object, and temperature is a physical property. We discussed physical versus chemical properties. So it's a physical property that tells us the direction in which heat will flow. So heat flows from an area, a warmer area, to a cooler area. And there are 3 different temperature scales commonly used. So Celsius, Kelvin, and Fahrenheit. The SI base unit of temperature is the Kelvin. However, the Celsius scale is the most commonly encountered scale in scientific work and in the laboratory. And as chemists, we must often be able to convert from one temperature scale to another. So conversion, and so we have formulas that allow us to do just this. So to convert between Celsius and Kelvin, we can use the following formulas. So Kelvin is equal to the degree Celsius temperature plus 273. Or if we want the Celsius temperature, it's the Kelvin temperature minus 273. And then here's the formula for converting from Celsius to Fahrenheit and from Fahrenheit to Celsius. And then derived SI units. So we have the SI base units, but we often measure quantities other than the 7 SI base unit quantities. So SI base units are used to formulate what are called derived units. A derived unit is obtained by multiplication or division of one or more of the base units. So for example, volume of a cube, so length times width times height, so all units of length or distance. So then the SI unit of length is the meter, so meter times meter times meter. So the derived SI unit is the meter cubed. Density, so is mass divided by volume. So we take the SI unit of mass and the SI unit of derived unit of volume, so which we just discussed was the meter cubed, and so forth and so on. So all of these are derived SI units. So using the base units, we can come to these other units, which we call derived units. So the SI unit for volume is derived from the SI unit for length, the meter. The derived SI unit of volume is the SI unit of length, the meter, raised to the 3rd power, meter cubed. And although the meter cubed is the SI unit for volume, again, this derived unit is often much too large. And so chemists tend to measure volumes using smaller derived units such as the cubic decimeter or cubic centimeter. And so 1 cm cubed is equal to 1 milliliter, and then 1 decimeter cubed is equal to 1 liter. And so this is a handy conversion to know. So 1 milliliter is equal to 1 centimeter cubed. But technically, officially, the meter cubed is the SI derived unit for volume. And you may have watched that video or choose to watch that video, but common units, common pieces of glassware used to measure volume. So we have a graduated cylinder, syringe. This is a burette, which we typically use in titrations. And then we have pipettes, and we have a volumetric flask used to make up a certain or desired volume of a solution. And so we could describe these pieces of glassware as to deliver or to contain. So if we want to dispense it or deliver it versus to contain. Okay, and then the next one, so we mentioned density is the ratio of the mass of an object to the volume occupied by that object. So the formula for density is mass divided by volume, so kilogram per meter cubed. It's the SI derived unit, which is often too large, so we use the grams per cm cubed, which is the same as grams per milliliter, because remember 1 cm cubed is equal to 1 ml. So density is a physical property, so think about what that means, and then density is also an intensive property, so think about what that means. So we discussed what we mean by physical properties and what's the difference between intensive versus extensive properties. But I want to show you a trick for rearranging equations. So let's say we had speed is equal to distance over time. So going across means to multiply. This line means to divide. So speed is equal to distance divided by time. Distance is equal to speed times time. Time is equal to distance divided by speed. So let's do one for density. So density is equal to mass divided by volume. So mass divided by volume. Volume is equal to mass divided by density. Mass is equal to density times the volume. So you can use this triangle to help you to rearrange an equation. Or you could use algebra if you're comfortable with that. But I like the triangle method. And then finally in this lecture, and there's a whole page within the module that I created based on accuracy and precision, but I'll just give an overview of accuracy and precision. So let's say we make multiple measurements. So whenever we make measurements, we want to be both accurate and precise. So let's talk about what we mean by accuracy and precision. And so these have to do usually with making multiple measurements. So accuracy is hitting the target, so correctness. So we hit the true target, and then precision is that the individual measurements or repeated measurements are close to each other. So consistency. So the terms accuracy and precision are often used in discussing the uncertainties of measured values. So accuracy describes how closely individual measurements agree with the correct or true value. So correctness. While precision describes how closely individual measurements agree with one another. Consistency. So hitting the target would be accurate, and then hitting the target every time would be precision. Or hitting this spot, we would be every time would be precise, but since you didn't hit the true value or intended value, you're precise but not accurate. And then if you don't hit the same spot every time or hit the right spot, then you're neither accurate nor precise. So here is an example of precision but not accuracy. Here you're both accurate and precise. And here technically, if you took the average of these points, you would get close to this bullseye, so the true value. So this would be described as being accurate but not precise. So we could look at the average, and then if the average gets us close to the true, then you're accurate because of the average, but you're not precise.